Hello, everyone. My name is Sandra Kim, the IA's Professional Development Director, and I want to thank you for joining us today. The Irrigation Association is excited to present a new series of webinars sponsored by manufacturers. The first webinar in the series, called Beyond the Controller, Reevaluating the Industry's Approach to Smart Irrigation, will be presented by Tucor. I have just a few housekeeping notes before we get started. This session will be recorded and all phones will be muted. This webinar is worth 1 CEU. A question and answer session will be held at the end of the webinar. If you have any questions, please type them into the question box on the right-hand side of your screen. The presenter will address them at the end of the session. Tucor is a manufacturer of control systems, interfaces, web solutions, and decoders for two-wire-based and conventional irrigation equipment to landscape, turf, industrial, and ag markets. Tucor has been in the irrigation control industry for over 20 years with continuously innovative and unique irrigation control systems. Tucor is proud to provide its customers with products and expertise alongside a robust network of distributions, installer partners, and service providers that guarantee the completion of a successful project every time. Our speaker today is Larry Sarver. Larry Sarver, founder and president with over 35 years of water management-related experience. Larry is a well-respected figure in the irrigation industry. Larry was the first to introduce two-wire technology to the domestic irrigation market and has since leveraged his breadth of experience to continually drive new innovations within the industry. Larry has been featured in various publications such as Irrigation and Green Industry magazine and currently holds 3 patents. Now, over to Larry.
Thanks, Sandra. So I thought today a topic beyond the controller. It's probably time that we start looking at some opportunities beyond the controller, things that help to contribute to make a totally smart system. So what we're going to do is look at some technologies that we've been working on to work from the valve box out and really from the controller out to help support the smart controller initiatives. So is your system really smart if some of these situations exist? If it's not connected to all of your valves, if you have independent battery controlled and operated valves, they're keeping your system from being compliant if you're getting rebates for your systems. There's liabilities associated with work crews, working medians, trying to schedule independent self-timing, self-operating nodes and things of that nature. There's issues with demands on the hydraulics, because all your valves are working over top of the primary controller because they're working independently of the primary controller. So there's a lot of issues associated with not being able to connect to all of your valves all of the time. What if there's no practical way to add additional valves? Think about how many lost opportunities you've had over the years for controller upgrades because you couldn't connect to the flow meter, you couldn't connect to the master valve, or you couldn't add enough valves to the system to justify a smart controller. What if it's not measuring flow? How smart truly is your smart system if you can't provide against leak detection, if you can't totalize the amount of flow that you're using on a daily, monthly, and annual basis? What if it's measuring flow, but not a high enough resolution at low levels for leak detection? With today's advancement of technologies of the drip and Some of these new systems with drip with filter fabrics on them, some of the lower flow emitters, certainly drip systems and green roofs. Low-level leak detection is becoming more and more of a concern. And what if you're not able to check the low leaks? So these are the things that we're going to address today. These are the things that Tucor has been working on. Everything from the controller out to help make the controller smart. So let's talk about this. We have 4 general categories that we're going to address today. We have the hybrid 3D system. We have the Nexus Wireless system. We have a new product that we're just introducing to the market currently. It's called the Tucor MultiFlow. And then the 4th category, which we're just finalizing right now, is the FMV, or Flow Meter Master Valve Retrofit Assembly. So let's take a look. Okay. We have the hybrid 3D, and this is a product where if you have just one good valve, one good wire in the system, we can add our hybrid 3D at your control system and use that existing wire and share the field common and add valves anywhere in the existing irrigation system. Not only can we add valves from that valve box out, but we can connect to a master valve and flow sensor and bring the data back to your controller, all without having to run wire from the controller. So we have 3 categories. New for us this year is our 3D2, which is a kit, an assembly just for master valve and flow. The 3D6 provides for master valve and flow as well, but also allows you to add up to 6 valves in the landscape. And then the 3D24 again allows for master valve and flow control, but allows you to add 24 valves into the landscape to help complete systems that you couldn't get wires to in the past. This is the basic configuration of the components that would make up the hybrid 3D system, where we have a small control unit converter at your controller. In the field, we have what's called our combination of 3D. It's got a flow meter and master valve capability built into it. So out of this single device, we can access and control the master valve, and we can also connect to the flow sensor. The unit has diagnostics built into it with LEDs indicating that you're in fact connected to the flow sensor, and as the flow sensor runs, you'll see a higher frequency of the white light. The blue light's an indication that you're in fact connected back to the controller on this converted 2-wire path. And then, of course, the green light is an activation that you've turned on the master valve. So any flow sensor that you want to work with, whether it's a rate of flow, high frequency flow sensor, or flow meters, or even the types that are a pulse per so many units of gallons, 1, 10, or 100 gallons. And then finally, as a part of this assembly, is our transition decoder, we call it, because you have to give up one valve, one good wire, to run the system from that valve box out. So we still need to control that valve. So we give you an assembly that has all of these components. So our first component, and which is totally new for us this year, is what's called our hybrid 3D FMV Assembly. And it comes as a complete kit. It comes as a kit with the splices. It comes with the transition valve decoder, the combination decoder, and with the 3D board itself. There's 2 ways to mount it. One is what's called a snap track. It allows you to hook a raw board to the wall or the interior of your cabinet, your controller, or you can mount it in this IP rated enclosure, and we have a flex conduit that can be cut to any size to fit the application. So that all comes to you as a kit. The 3D FMV Assembly is shown here in a package that comes in the box with the instructions on the box itself for use. We have the 3D6 and the 3D24. Again, and sometimes you don't need to add it to flow meters and master valves, but you just want to add additional valves to your system. Oftentimes I've had as many as 2 of these placed on a controller just to add valves where needed. So this is kind of a layout, a configuration that shows a typical application. So number 1, what we're showing here is like we're adding a combined flow sensor and master valve by using the existing wires. So here's the controller location. We have all the existing wires to the existing valves. We come down to this last valve because I want to put a flow meter and master valve at the point of connection. So we end up going to the transition valve right below in this area here. We transition that wire by putting a decoder there. So that valve now has to have a decoder talking to that solenoid, and then we can add a master valve and flow sensor to the system. The second would be we can in this case we're eliminating a broken wire. I've got one good wire crossing into this median to this island. One wire is broken. All I have to do is go to the valve that's got the good wire, put a transition decoder in, and then add as many valves as I would choose at that point. We have the ability, if you want, as in this example, assuming your controller had the ability to work independently with an independent schedule that didn't have influence with the range shutdown, you could actually run lighting features and so forth off of your controller as well by extending the 2-wire path to it. And then finally, we have another option where I've got another controller and I want to eliminate one of the controllers because it costs money to get into servers and telemetry. I can actually group controllers, eliminating this controller, and out of the 3D actually run a small 2-wire path to pick up the extra valves. So that's one way of eliminating reoccurring costs. So here's a perfect example of a project where this occurred, where we had, you can see this is where the yellow star is. It was a controller. It was landlocked. The closest valve to the point of connection where the orange is. So they just put in a 3D, converted that wire, ran 60 feet of new cable to the point of connection. And there they had what's called a hydrometer and a decoder at this point. And in this project, villages in San Jose, they put in 109 of these, and it saved them thousands of dollars in trenching and boring. So that's a perfect example of how you can resurrect projects that otherwise wouldn't be feasible to do. So here are some mounting examples of what the 3D would look like, where you've got the unit with the flex cable coming out. It can come out from the top and curve. It can come in from the bottom. The flex conduit can be cut, and you can set it up adjacent to the unit, so it's totally flexible. We also have what's called a snap track. It's a plastic frame that you can actually snap the board into and mount it inside your cabinet if space is a constraint. So that's the hybrid 3D. Think now that any valve wire in the field, you can add as many valves as your controller has a capacity, up to 24. You can go in multiple valve boxes throughout the site and continue to add valves as long as the wires going to those valves are good. Our next product feature is Nexus Wireless. This is a product we've been working with for about 5 years now, and we have a lot of categories to the wireless. wireless flow, and we'll get into a little bit more of that later on in the presentation, but that's a pretty extensive capability that we have now. We can add flow, unlike with the 3D where you had to have one good wire. With our wireless flow capability, we can, of course, bring wire flow in from really anywhere. Our systems have the ability to connect to repeaters, so distances really aren't a concern. Our RKW is our totally wireless controller, wireless to ET, wireless to moisture sensors, wireless to valves and flow. Then we have our wireless valves. We can make, and all of these products that I'm talking about so far are can go with any controller, any system, anything in our Nexus platform of products. This is all available to connect to any manufacturer's controller. So the Nexus Base, I can make any manufacturer's controller connect to wireless valves. We can connect up to 6 wireless valves to any manufacturer's controller. We then have our Nexus Link, which is more of a centrally managed wireless valve system, up to 50 plus wireless valves per gateway, and we can monitor the system remotely. In fact, we insist that sites that are that large that we are able to monitor them remotely, so there's always a cellular gateway involved. So this is kind of the topology of what our Nexus Base looks like. Here at the top in the center, you see the radio gateway that attaches to any controller. It's just a simple terminal strip that any controller's valve output in common connect to this relay, and it actuates the valve through the radio. These are 900 megahertz 1 watt radios, and the wireless components could be an above ground enclosure. We have valve boxes that go in the ground, and this is an example of the radio receiver. All of this equipment has built-in site survey capabilities. Also, we can control a switch or a valve through the same device. I can not only turn on valves in the field, but I can turn on pump starts, master valves, really anything that you need to turn on with a switch, this infrastructure can manage. Then we go to the Link. And the Link is now a little more complicated because we actually have a small little PLC in the control environment. We can work through cellular, local networks, or a 900 megahertz Ethernet radio to get this connected to the servers. While we prefer to put in our controller at this because we pre-program and build everything here on large applications where there's an existing central control system, we would certainly work with you in that situation. We can do up to 50 plus valves. I have a couple jobs with 60 to 70 valves per gateway. We can also do moisture monitoring for moisture probes. We have probes from 8 to 60 inches in length, up to 5 probes per radio, 20 radios per gateway. We can do master valves, pump starts. We can bring back flow, pressure, pH, conductivity, humidity. All of this is still within the same radio network. We can strengthen any of these signals through repeaters, up to 4 repeaters going further and further out into the network. And then we have, of course, 2 power sources, one being our 120 volts AC and solar. We have a project that's got over 28 solar powered repeaters on it. So this is kind of what you would see as far as equipment's concerned. This is our wireless flow transmitter that you'd find in the field. This is our totally wireless controller. And then this is an example of what our base system would look. It would be just a conventional controller outputting to a terminal strip, connecting to a radio, out to your valve box. To the right then is our Link system, where we have a small programmable controller built into it. And with all of this equipment, you can do a site survey locally at the equipment, or in this case, I can do site surveys, which we do once a month for our larger applications. We do site surveys. So here's an example of a project where with one distributor in this country. We've got two projects, two ends of the country. One was an HOA, and these are all going in right now as we speak. An HOA in Florida had 11 controllers. We narrowed it down to one of our 200 station controllers, and that was the first phase to get the control system to where we eliminated their 11 controllers in the field. And then their plan was to change out the valves as the valves failed over time, because it was a 30-year-old HOA. 2 months into it, they said, forget it, let's just do the whole thing. So we just, this Friday, will ship the last of 200 wireless valves for that application, which is going in right now. Then another project in Folsom in California, the other side of the world. As you can see, it's a fairly large project. It's got the red of the repeaters. It's a HOA, and it's got 11 wireless controllers and 28 repeaters and over 300 wireless valves in that project. This is an example of what it looks like installed in the field. In this case, as you can see the canal in the background, this is in Phoenix. One of the canals going through, the irrigation canals going through the city, and they're re-landscaping the entire property. There's no power, no access to get power to the controllers, plus the vandalism concern. So as you can see, the valve boxes, and we place our wireless valve in a what's called a Dura dry box adjacent to the valves. To the right here, you see an application where it's one valve, one radio, one valve, and so this is just a small example of the 300 units that are going in California. So that's our wireless valves examples. Our next product is MultiFlow. We're just releasing this product. The MultiFlow is a universal product. It does a lot of things. It'll combine two points of connection and hand it to a controller for those controllers that only have the ability to handle one point of connection. It will take a flow input and divide it and hand it to two devices. So if I have a controller and an injector, and I need to hand flow to both units, well, it's optically isolated where I can pass that through. I can also manage 4 wireless valves or flow meters and 2 hardwired flow meters, and combine that at the controller. This is a kind of a look at how this comes together. You have the transmitter for your wireless flow. This is the gateway at the controller. This is what it would look like if it was in its own enclosure. We can work with any manufacturer's flow sensors and meters, and we have this different topologies where we can do star point to point, and we can actually put repeaters in where necessary. So this is kind of a breakdown of what this thing will do, and this is what makes it even that much more unique. Is you see these 6 switches at the top. The first 2 are for the wired. The other 4 are for wireless. We actually can hard code in all the K factors and offsets of the various manufacturers' flow sensors. So when we ship it, you tell us what size valve or what size sensor and what manufacturer it is, and the K factors and offsets are already built into it. So you can combine different manufacturers with different sizes in this system. We have test capabilities where you can test the pulse to the controller to make sure that it's wired correctly. We can test the radio signal if it's using radio to see if it's radioed correctly. And here in the bottom, you see I got 2 flow in where I can hardwire 2 flow sensors. And I got 2 out if I need to send it to a controller and an injector or something of that nature, or even 2 controllers. So this is what that board looks like in an enclosure, clear or opaque. We also have the ability to then bring in a radio to it if I'm bringing in wireless. So this is all, as I mentioned earlier, this is all products that can be used with anybody's equipment. That's what the whole Nexus line's about. So now we're going to talk about a product category that's kind of unique. It's our FMV flow meter master valve retrofit assembly. In essence, what this is we combine a flow meter, we combine a master valve, and we run that through our MultiFlow board, and we're able to take these custom K factors and offsets and give them to any controller. And the big difference to all of this, as this assembly comes out, is, as you'll see here in a moment, that we totally eliminate the 10 diameter rule in and the 5 pipe diameter rule out. We actually butt the master valve and flow sensor against each other, and we can pipe directly into it through elbows. We can pipe out through elbows, but we have all of this tested, and each one of these has a unique K factor for our assemblies hard-coded into this board. So this is kind of a look of the topology of that. We have the master valves that we're working through with Superior. We have the new ultrasonic flow meter, which allows us to have this capability and flexibility of eliminating the 10 and 5 rules, and also helps us pick up absolutely low flows. We can pick up flows from a weeping valve. That's how accurate it is at such low flows. We have multiple configurations, which I'm about to show you, and how that goes together in the field, either in a straight line, in above ground in a cage, or as a submain, as we call it. We can bring all of this data back to your controller, either through our hybrid 3D that we talked about earlier, or our wireless valves. We can power the wireless valves either through 120 volts solar power, or a product that we have in development right now, a inline turbine hydro generator. All of this is fed through our configuration adapter, our MultiFlow, based on whatever configuration and size we're using, and I can hand this to any manufacturer's controller, any existing application, any project where you need to bring flow and master valve down in a confined configuration. You'll be able to do that now. So the retrofit assembly is new for us. It combines the ultrasonic flow sensor and brass master valves, and it's designed to be built into confined spaces, all without the 10 and 5 diameter output rule. It's available in 3 configurations currently, four configurations: inch, inch and a half, 2, and 3. Each assembly will ship with a wet calibrated ultrasonic flow meter, and a little bit more about what that means here in a few minutes. A brass normally open or normally closed master valve, and either a box or a cage enclosure, however you've configured it, along with the Tucor MultiFlow adapter, which makes all this possible. So these are the configurations that we're coming out with. We have our straight line for installations where the master valve and flow sensor are directly connected. We eliminate the 10 and 5 diameter rule. Again, it's ideal for tight spaces in a retrofit environment. For instance, for situations where we need to be above ground, we're out in a park environment where this needs to be above ground in cages near your backflow preventers. The flow sensor is mounted vertically, and the master valve horizontally. And again, it's ideal for tight confined spaces. And then our third configuration is what we consider and call the submain, where you've got a main line at a lower depth, running vertically and then horizontally straight out of a 90 into the flow sensor, into the master valve, and out. And all of these as I mentioned earlier, are ideal for retrofit. And all of this product that we're talking about really addresses the need for the retrofit markets. This is ideal for all of these applications that you have where flow is required, metering is going to be required, and you need to cut it into a confined space. And then what makes all this work is that all of the testing that we've done for each one of these unique configurations, all that calibration is embedded in this MultiFlow board. You hardwire from here into the MultiFlow board, out of the board into your controller with the presets already built in with the calibration factors that have been tested for. So with this MultiFlow board, I've got 16 preset calibrations. I can do 2 hardwired and 4 wireless. And as mentioned earlier, 2 optically isolated outputs for multiple devices. You have 2 options for mounting of this. It can be in your cabinet with a raw board on our SnapTrack, or we can give you an IP-rated enclosure mounting that I'm showing you here. So this is all product that's been calibrated, verified, and tested in a lab. This is kind of gives you an idea of what a straight-in flow sensor, straight-out master valve is going to look like. It will come in a already built as an assembly. We will feature Victolic couplings for ease of taking them in and out for service. And like I said, this is an example of the testing we've been doing. Another example is our above ground cage, as I call it, for a lot of the West Coast applications where this is at ground level, this is above ground in the cage. You see, we've been, again, doing testing, and each one of these, of course, as you can imagine, with the various flow distortions coming in and out, generate a different calibration factor. But the beauty of this ultrasonic technologies, it's not impacted by the turbulence that your standard paddle wheels that are out there currently right now. So it's totally new. Well, ultrasonic's not new, but it's new to our industry in that it's now affordable. It's at the same price points as the paddle wheel technology that's out there right now. And then one final example of then we just have a unit with maybe it's a main line. We're doing a SubMain with a 90. Again, the ultrasonic sensor and master valve. So just a little discussion, I guess, on what you're probably accustomed to as opposed to what we can provide for you now. What you're accustomed to, of course, is flow sensing. You've been looking for broken or missing heads, maybe even nozzles if you have the low flow capability. Certainly line breaks and hopefully leaks if the leak is big enough that your flow sensor is going to pick it up. Clearly, you've been looking for unscheduled flow, any valve breaks. These are all things that we're all accustomed to our sensors providing us. Now, what a flow meter does is it's a little bit different. A flow meter is something that actually is, in at least from our perspective, is something that is measuring water on a continuous rate, as opposed to flow sensors. Their calibration is usually at the highest flow rate, and so at low flows, the accuracy for actually determining water usage, water consumption by an agency, it's not there. You know, they call it full scale, and that might be at 30 feet per second. Well, whoever designed an irrigation system, it's at 5 feet per second or less. So that's where the sensors, the ultrasonic, really show themselves, because they're very, very accurate at these very low flows. So you're going to see more and more water consumption required by a lot of local governments and agencies. The ultrasonic can produce accuracies better than a lot of paddle meters that are actually, or the meters that are used for residential and small commercial applications. It's much lower flows for drip lines, for these new other technologies coming out with much lower flows than what have been seen before. And now you have to look at control systems. Can they actually record flows in fractions of a gallon as opposed to whole gallons? So what we're talking about is it a flow meter or is it a flow sensor? And in some cases, a flow sensor is just fine. You just want to pick up unscheduled flow or a mainline failure. But the future is going to, in all probability, dictate that you're going to have to start recording consumption. It's already mandated in some municipalities. So a flow meter is accurate across the entire range of its flow, and it's accurate at very, very low flow rates. It picks up very low flow rates. It's wet calibrated. Each ultrasonic flow sensor is actually calibrated in the factory before it's shipped. So it's ideal for low flow detection, and it's very accurate, as opposed to a paddle style sensor that it's rated at full scale, as I mentioned earlier, and full scale is at the far end of the range, where most systems, I mean, if you turn a system on and run it full flow the entire time, that's probably good. But as you well know, most of these irrigation systems you design, the flow's all over the place. So low flow, high flow, and back and forth. So that's just a little bit about why we are tied up with these new ultrasonic flow sensors. It allows us to build these retrofit kits by eliminating the dimensions of 10 in and 5 out, and giving us accuracy for actually reporting consumption in the future. So if you're going to be changing out your meters, you would, I think, be well served to at least anticipate that someday you may be required to account for consumption, and these systems now will do that in the event that that's required. So I want to just show you a little bit about just how accurate they are at low flows. If you're all familiar with excuse me, your flow sensors and their performance, this 1-inch flow sensor is 1/10 of a foot per second in velocity. At 0.22 gallons per minute is our minimum operating range. 1.5 inches, less than 1/2 gallon a minute. 2 inch, still under a gallon a minute. It's accurate on a 2-inch line. 3 inches, 2 gallons a minute, and 4 inches, 3.5 gallons a minute. So it's very, very accurate to low flows, allowing us to pick up, as I mentioned earlier, leaks that you couldn't pick up in the past. It's one thing for a valve to close on a rock or some debris, you're going to get a lot of flow. But if you've got a diaphragm that's worn, or pebbles sitting on a diaphragm, this is what's going to pick that up for you. So a little bit about these ultrasonic flow sensors. Higher accuracy. This is 2% across the entire range of the flow, not the full scale or the full end of the range of the meter. Fractional gallons per minute, as I just showed you. It's made as an insert to replace the systems out there that have inserts. There's no moving parts. If nothing else, that in itself is a reason to take a look at these ultrasonic flow sensors. And I think you're all going to see more and more of this. It's starting to really hit the street now pretty hard. So this will become a household term here in the near future. Leak detection down to, like I say, 1/10 of a foot per second or lower in some cases. And then it's got diagnostics built into it, just as our 3Ds do, where you've got a light for connection and a light for activity. And it's NSF certified for potable water applications. That's how accurate it is. And you're going to start to see more and more of that. And then to wrap this up, we've partnered with Superior on their master valves. They've been in business, I believe, about 80 years. So we have the opportunity to provide a normally closed, normally open, purple cross handles for applications that need that. They have valves that have a no minimum flow feature, because in the past you always had to have a certain amount of flow for a valve to actually work. So in these low flow environments that we're talking about, there's an opportunity for minimum flow to no flow valves. And they've got pressure regulation built in where needed as well. So we've partnered with some of the very best technology, some of the newest technology, to be able to bring you this new retrofit assembly. And we're pretty excited about it. And we're just coming to market here within the next couple of weeks with this completed assembly. So that wraps up. That wraps what I have for today's conversation then. So I believe it's open for questions at this point.
Hi, if anyone has any questions, please type them in the question box on your screen. As of now, I don't see any questions. While we're waiting for people to type up, Larry, do you want to say anything to the audience or any summary? Oh, go ahead.
Well, it's just that, I appreciate this opportunity to be in front of everyone. Anybody that's taking the time out in the middle of the day to sit through a webinar is obviously wanting to take things to the next level, to the next step, and I appreciate having an opportunity to be heard. These are all really, really interesting projects that we're involved in, and just look forward to an opportunity to discuss it at length with anybody that would like to discuss it.
Okay, so there are questions coming in now. One of the questions is, so the feature is not 2-wire but wireless, correct? I guess they wanted some clarification.
The feature, well, it's two components. The 3D that we spoke about earlier is using the existing wire, but we connect from a valve box and then basically run 2-wire from that point. So we're able to what we've done is we've been able to take 2-wire technology and put it on just 1 wire, so we can use one good control wire and share the common of the existing system. So from that valve box out, when I'm running to the master valve and flow sensor, or when I'm adding more valves, that then becomes a 2-wire system. So we've created 2-wire out of a 1-wire capability, and it's from the valve box out. The rest of the stuff we're talking about is, yes, it's all wireless.
Okay. Another question they had was, for ultrasonic flow meters, how do you get the readings?
Well, the reading, it's like any flow sensor out there. They've got 2 wires that come out, and they can wire direct. If you're just going to, you can buy these sensors direct now through distribution, and you can wire it directly to your controller, and you just plug in the K factors and offsets, And if your controller can read flow, you're in business, just like any flow sensor that's on the market. It's just in our situation, because we've got custom special calibration factors because of the configurations that we're providing and the fact that we're eliminating the pipe diameter rule, so to speak. Those custom calibrations are built into our MultiFlow board. So you have to connect from the flow sensor to our MultiFlow board to your controller. If you don't have wires to do that, you've got one good wire, you can use our 3D to connect the sensor to your controller. If you don't have anything at all, you can use our wireless. But we're just basically passing that signal through to your controller as if it was any other sensor running wire and signal to the controller.
Okay, we have another question. It says, what would be an estimated cost to retrofit a 12-station system to fully wireless system?
I understand the question. You would, depending on the circumstances, the distances, and so forth. You've got to figure roughly at a list price of roughly in the neighborhood of $1,000 a valve.
Okay. The other questions that they had was, will this presentation be available to attendees? We are recording this presentation, and we will put it up for future viewing in a few weeks. So we will send a notice out to everyone when this is ready for viewing, but it will take a few weeks. There were just no other questions, just a lot of comments about the presentation itself, and that they appreciated it.
That was good.
So I'm looking for any other questions if anyone has it. You got a lot of thank yous for the presentation.
Great.
Okay.
Thank you, everyone.
Yeah. Oh, is there any training to process? Is there a training process to install systems?
On the wireless, yes, we have a small training program. All of the wireless we will not sell unless it's been surveyed in the field, and whoever's doing the work has been through a small training program we have. And we come to you to do that where necessary on a certain scale of projects. We have distributors set up around the country that have the site survey equipment scattered throughout the country, so they can come and help you do the site surveys. But we will not ship a system unless it's been mapped as a Google map, and then it's been surveyed, and we won't warranty it unless there's a as-built, as-installed site survey, so that we're assured that it meets our standards.
Are you training at the show, the Irrigation show coming up in Las Vegas this year? That's a question that popped up.
Well, hadn't thought about that yet. I know we do an annual training in Las Vegas ourselves in February, which we have a very comprehensive 2-day program. That if anybody would be interested in signing up for that, we'd love to see you. But beyond that, we'll be doing regional trainings through a lot of the big distributors, and we'll certainly be willing to make special arrangements for somebody if they need some special one-on-one training.
Okay, so I have 2 other questions that popped up. When adding a 3D device for flow sensing at any existing controller, does the controller have to be flow ready?
Yes, we can't. All we are is a conduit to bring the information back on your existing wires. We can't, and we have to hand it to the controller. So unless your controller has the ability to read and react to flow, we can't help you. Of course, we can sell you. We could happy to sell you a controller of ours that does that, but no, you have to have the ability at the controller.
So the next question is, what is the product warranty for wireless valve operation? Can the
The
wireless boxes be submerged in water? I guess it's a two-part question.
No, they're electronics. They don't like to be submerged in water. We put them in a Dura dry box, which we have found to be, I'm not going to say it's waterproof, but it is watertight. On our bigger systems, we put floats in the bottom to warn if there's any water intrusion. Um, but if installed properly, they have gaskets. They got two bolts to bolt them down. We just haven't seen. In fact, we've immersed them here in our tanks for days, and water doesn't get in them. That's not to say that somebody could crack it by putting the bolt down too hard or doing something. We've seen them try to pry them open without taking the bolts out. Water will get in. But no, they're electronics and they're not warranted against submersion. But we have a 2-year warranty on the radios in the field. But we will not warranty anything unless the final site survey is in place. What happens is, the batteries are good. They're 1 watt. These are DC latching solenoid products, and it's a 1 watt radio, and it's rated for several years of activity of on and off, assuming that the radio signal is strong, meeting our standard. If the radio signal is marginal, it's going to take more attempts for the radio to reach it, and as a result, the battery in the radio will be compromised over time, which means you're changing batteries out, which means you're opening up valve boxes and so on and so forth. So this is our 5th year into this. So we've seen a lot, and we're still learning. But if you follow our instructions, you'll be well served.
Okay, the questions keep coming. So the next one is, what is the maximum distance for wireless valves, and are they line of sight?
Okay, so it depends on the application. The wireless valves, if we're talking about worst case scenario, that they're in the turf, and the controller gateway is at a radio at about chest height, you can figure about 1,000 feet without issue. We go further if the antenna is higher at the gateway. In that project in California, we can run through repeaters. I've got almost 30 repeaters hanging on streetlights, where I can take the signal from the gateway, from the controller, and repeat it up to 4 times before it goes down to a valve. So we've never been skunked, so to speak, on getting something to work. It's just a matter of working through antenna placement, height, and whether in fact we do need a repeater or not. It's 900 megahertz, so if you're familiar with it, it's very, very strong in penetrating buildings, as long as it's not all metal, concrete block and so forth. It goes right through buildings. It's pretty good with landscape. What it doesn't like is fine pine needles and mesh fences. It doesn't like that, but if it's out in the open, we've gone through several walls of buildings with this stuff and had impressive results.
Okay, so the next question is, should the ultrasonic sensor be removed from the flow meter before winterizing the system with compressed air?
No, that's the beauty of it. You don't have the issues that you have with paddles with compressors running. No, you can winterize them without, it's just little electrodes that are right in the base of the wall of the meter itself, and so no, that's not an issue at all. It's really a low maintenance as compared to what's out there right now. It's a very low maintenance application. That product, incidentally, won Product of the Year award at the IA last year, if anybody can remember that. So it's backed by, I don't make it. It's backed by a company called Great Plains out of Wichita, and they're a huge company, and they're all over the world with what they do. And this is just a small part of what they do, but you're going to be hearing more and more of them in the near future as they get more and more creative with applications in the landscape industry.
Great. I remember that for sure. The next question is, how well do any of these applications work with photovoltaic equipment installed on site?
Well, that project in California with 28 or 30 repeaters are all solar powered. So, yeah, I mean that's a big part of what we do. You know, there are some projects that have, well, that project in California, it's solar power to the controllers, it's solar power to the repeaters, and of course, it wouldn't be practical to do it at the valves. But so yeah, that's all very much a part of what we do.
The last question is, do you have a rep in Southern California?
Yes, I do. Yes, we do. We actually work through a rep agency there, and we have 3-4 distributors there. Some of which are very, very heavily involved in what we do. We've been working actually at the Disney facility for the last 3 years with our radio system for moisture probes, but we do have a few wireless valves there as well. So we do have solid representation in Southern California.
Okay, so the rep question continues. Do you have one in Western Canada and Alberta?
No. That would really be handled by us directly, because we don't have, we're doing work in that area in ag, but we don't have a direct rep there. So that would come and be serviced through us, in which we do without issue.
Okay, great. Well, we're nearing the hour, so it looks like we are out of time. Thank you for questions. If anyone else has a questions that weren't answered, then please send it to me at education@irrigation.org, and we will pass it on to the appropriate person. Thank you, everyone, for attending, and don't forget to check out our website for upcoming webinars during the year. A big thank you to Larry for sharing his knowledge with us today. Have a great day, everyone. This concludes our webinar.
Thank you.